In this video, we will solve a question on Solow model. The question is, consider a Solow model in which output y is determined by the production function, that is yt is equal to 0.2 kt plus 0.8 lt, where k and l denote the capital and labor and t depicts time. The depreciation is given by del kt, where the value of del is 0.2. Saving is given by, that is SYT, where S denotes the saving rate, which is equal to 0.5. Assume that population does not grow with time. The steady state capital per unit of labor is we need to find out. Okay, so what we are being given here, let's write. We are being given the production function, that is capital Y T is equal to 0.2 K T plus 0.8 LT. This is our production function. Also, we are being told that depreciation is being given as a 0.2 and saving rate is small s is being given as a 0.5. Okay, we need to find out the steady state capital per unit of labor. Now, to solve the Solow question, what we do first, we write the given production function in intensive form. Okay, we write the given production function in intensive form. By intensive form, what we mean in per capita form. That means we need to divide the given production function both sides by L. Okay, to write the given production function in per worker form. So we have YT, to this we divide by LT, should be equal to 0.2. We are dividing both sides by LT. Okay, so we have here KT divided by LT plus 0.8 LT divided by LT. Okay, so our production function in per capita form is, let us denote YT upon LT by small yt. So it denotes the output per worker, okay, is equal to 0.2, and KT upon LT, let us denote it by small kt. Okay, let us denote it by small kt. Let us say this denotes small k. I get confused how to write this small k here. Okay, let's write it in this fashion. So we have this k t plus 0.8. Okay, this is our per capita production function. Okay, that is output per worker is a function of capital per worker here. Okay, now we also know in the Solow model that savings are equal to investment. Okay, now if savings are equal to investment and savings are being given us here as SYT. Okay, so in place of this capital YT, we will write small yt, because we are writing the given variables in per capita form. That means small yt will be equal to IT. Okay, it simply tells us investment per worker is equal to saving rate times output per worker. Okay, and we assume that savings are equal to investment in the Solow model. Okay, also we know that in Solow model, or let us first write the fundamental equation of Solow model. Okay, what is the fundamental equation of the Solow model? They tells us the change in the capital stock. Let us denote it by, okay, I am writing this small kt. So change in capital stock is actually equal to investment per worker minus the depreciation rate times capital per worker. Okay, this is our fundamental theorem of Solow model, rather the fundamental equation of Solow model. What exactly does this tell us? It simply tells us that the change in capital stock, okay, let me write it here, the change in capital stock, okay, change in capital stock is actually equal to the investment minus depreciation. If you are wondering how do I write this very equation of Solow model, I have explained this in my earlier videos on the introduction to Solow model. Okay, given this fundamental equation, it simply tells us that change in capital stock is equal to the investment minus depreciation. Now at steady state, since we have to find out the steady state capital per unit of labor, at STEADY, steady state, what happens at steady state? At steady state, del KT, that means change in capital stock is equal to 0. Okay, it simply tells us investment is just enough to cover for the depreciation at steady state. Okay, whatever we are investing is used to cover the depreciation, so the change in capital stock is 0 at steady state. Okay, so if del KT is equal to 0 in this equation, that means I is equal to investment per worker is equal to del times KT. Okay, now investment, as we know, it is equal to, let us write it here, investment is equal to S times YT. It should be equal to the depreciation times capital per worker. Okay, now savings rate is being given us here 0.5, so we can write 0.5, and YT, we have calculated YT is equal to 0.2 KT plus 0.8 should be equal to, what is the depreciation, that is 0.2 times KT here. Okay, that implies when we solve this, 0.5 into 2, it comes out to be 0.1 KT plus 0.5 into 0.8 is 0.4 is equal to 0.2 KT. Okay, transposing this 0.1 KT to RHS, it implies 0.2 KT minus 0.1 KT comes out to be 0.1 KT is equal to 0.4. Okay, so it will be equal to, KT will be equal to 0.4 upon 0.1, which comes out to be 4. That means capital per unit of labor at steady state is equal to 4. And graphically, if I have the space, let me show it graphically. So let us try to draw a graph here. Okay, so I have to be very cautious about the space that I am endowed with. So let us say we have capital per worker on the horizontal axis. Okay, let's denote it by, okay, so let's write it K, and let us say output per worker is being denoted on vertical axis, sorry. So this is our production function, and its intercept is 0.8, and we have, let us say this is 0.8, this is our YT, Okay, output per worker. Also we have the savings function SYT. Okay, where is our savings function? That is SYT will be equal to, it will look like this, 0.5 into 0.2 is, this is actually our savings function, and let's draw it here like this. Then we have the depreciation function, and we can write it as del kt. This is our s times yt. Okay, so at steady state what happens, depreciation is exactly equal to the investment, which is equal to the savings. So it happens when output, rather the capital per labor is equal to 4. Okay, I hope I make myself clear in this video. Thank you.